All right, good afternoon, everybody. Thanks for hopping on here with us today. Really excited about today's topic. First, I feel like I never introduced myself, but for those who don't know, my name is Maureen Gribble, and I work with UE Systems. And yes, I am the one you get all those wonderful emails from. But really excited today to have Lucas Marino with us. He's going to be talking to us about sustainment engineering for asset management. So pretty cool topic for us, and obviously generate a lot of interest. So we've got a great group signed on with us today. So looking forward to what Lucas has to share. Before I turn things over to him, always like to go through sort of some housekeeping items. So for starters, we are recording this. So Lucas was kind enough to let us record this. So I will pop it up on our website and share a link out to the recording on LinkedIn and Twitter and things like that. So if you have to hop off early, or you've got a colleague who wanted to join but just wasn't going to be able to get away, we'll make this available for you to listen in on later on today. And then we certainly welcome questions. You know, we try to make it as interactive as we can, with everybody being kind of spread out throughout the country, but definitely type those in. I'll be keeping an eye on those, and I will get those tossed over to Lucas as it makes sense, as he's going through, if someone needs clarification on something, or of course we'll have some time for some Q&A at the end as well. And then I always like to just remind everybody we are doing this live. It's kind of fun that we're able to do this and hopefully, you know, get in on your lunch breaks. And I know we got folks doing lunch and learns and things like that. But of course, with that, you know, there's always that potential for my internet going out or audio issues, things like that. So just know that we will, if we come across any of those, we will try and resolve them just as quickly as we can. But just bear with us if we do stumble upon any of that. And so with that, I am going to turn the screen over to Lucas. So you'll have just a momentary pause here and let him take it away.
Thank you so much, Maureen. I appreciate that. First of all, I appreciate everyone calling in. This is kind of a fun topic for me and a new topic for many in our audience, because sustainment is a term that is very heavily used in the Department of Defense and the Department of Homeland Security in the United States as one of the parts of the life cycle of an asset, one of the phases of life cycle management for an asset. And part of my mission when I left the military was to help spread that love to industry. So I appreciate the opportunity that you're giving me to come on and talk a little bit about sustainment engineering and a couple of the familiar items that are already wrapped into this world to help, like FAMICA and FAMIA, and some new ones. So appreciate the invite. So, all right, well, we'll go ahead and get underway here. Can you see my slide deck, Maureen? Are you good with that?
Yes, it looks good.
Okay, perfect. All right. So the sustainment engineering is, a very heavily used term, heavily referenced phase of life cycle management in the United States military, because they procure and maintain and operate such a large variation of critical assets, and they do so basically around the clock, 24/7, 365, regardless of whether we're at war or in a time of peace, because we're always maintaining a state of readiness. And so because of that, we have a very large asset manager on our hands here with the military. An example that I put on this slide is this brand new, beautiful landing craft that the Army is building with us at BMT. This is a very unique asset that carries a tank from a pier or from a ship to a shore, and moves at a great speed and can deliver a lot of power and capability in a shorter amount of time than previously done so. And because of that, this asset has a tremendous amount of value, not only to the Army, but to the people operating it, right? And it also has a tremendous amount of value to the people that funded it, and that would be the U.S. taxpayer. So we have to make sure we do the right thing by the taxpayer and the right thing by the Army in developing the appropriate level of analysis to support the asset, okay? And so the first phase of the life cycle will be acquisition. And in acquisition, we're designing this thing. So we're going to do a lot of analysis in the design phase to start and influence the design. And then as the vessel transitions out of acquisitions into sustainment, we will iteratively continue those analysis to refine the maintenance concept. So it's kind of sustainment engineering and integrated logistics support, as it's commonly known in some branches, is kind of making a little bit of a resurgence in the military. It's getting a lot of headlines. As you can see here, we've got, military generated or focused publications, both in print and in digital media, and even official government documents talking about how maintenance and sustainment of maintenance in the field and the sustainment of the assets themselves is kind of taking a bigger part of the spotlight these days than it had done in the last few decades. When you go into heavy use of assets, you tend to focus pretty heavily on operating, and you sacrifice a lot of things to do that. And people in the production world know this very well, because production rules everything. It's operations drive all things, and so the maintenance has to fit in partnership with that, but sometimes takes a back seat to operations. And unfortunately, that happened in the Department of Defense and the Department of Homeland Security with a lot of its aging assets, where we weren't able to keep up with the maintenance. And then newer assets that were being delivered quickly because we were in a time of conflict and we needed these assets out on range. And so there was less of a focus on all these different but similar phrases for sustainable, supportable, maintainable, and reliable assets. So it's kind of created a bit more of a resurgence in the military side, and people on the outside of the military are starting to really catch on to the rigor that is applied and how valuable this is to managing very valuable and expensive assets. So a lot of our listeners may be familiar with FAMICO, which is the failure mode effect criticality analysis. The simpler form of this would be FAMIA. But many people in industry don't understand that there's more that follows on after that in the world of sustainment engineering. We move right into things like maintenance allocation charts and maintenance task analysis and level of repair analysis. And we do all of these things to develop a very robust, capable, and efficient and effective maintenance concept. And so, my hopes in this presentation are that I can show you that through the work that you do up front and then the iterative analysis that you do across the life cycle of an asset, you can really create the most efficient and effective maintenance concept possible for your asset. Okay, so these are a couple of things we'll cover. So if you're an asset manager, no matter what industry, if you have large, complex systems, expensive, valuable, impactful operational systems, you're going to have a lot of these responsibilities assigned to you as an asset or maintenance manager. Many times, if you're doing both. And we need a few things on this chart to be called out for the sake of this presentation, because they align specifically with our goals for sustainment engineering, and that would be that we need to determine and manage life cycle and renewal costs. We need to optimize our operations and maintenance, and not just the finances, but the actual performance, right? We want to optimize the output of operations and the effectiveness and efficiency of maintenance. We also need to develop a funding strategy as asset managers, and every maintenance manager answers to a budget, right? And then of course we need to if we're actually performing and functioning in a realistic and healthy asset management organization, we need to have the appropriate type of asset management plans for our equipment and systems. So all of these AM/maintenance manager tasks are supported by sustainment engineering analysis. So what the heck is this stuff? Well, we're going to support in-service systems, okay? So remember, when we're talking sustainment, we're talking it's been purchased, it's now deployed, it's now in operation, it's now being used. And we're going to take the same approach in acquisitions with these types of analyses, and we're going to iteratively reuse them in the sustainment life cycle phase. So you bought something, it's really important. You can't afford to mess this up. You put it into service. You can't stop analyzing and stop paying attention to cost drivers and maintenance. We've got all these different ways of doing it out there. And what sustainment engineering does is it applies some fairly rigorous supportability analyses to that effort. So we're going to look at everything from technical tasks, which are involving our engineering and logistics analyses, and we're going to be looking at trying to maximize our operation and maintenance of our systems. Now, we also need to identify, review, assess, and resolve deficiencies throughout the system's life cycle. And these analyses will give us the opportunity to do that in a very defensible way, which matters quite a bit when you get to the more senior levels of an organization. You can't just make a claim about what you need for resources, whether they be money or people or equipment or tools or whatever. You can actually prove that through some fairly dependable analyses by doing this. So it's the whole deal, man. I mean, sustainment engineering is basically kind of wrapping all the support that it takes to keep this thing operating at its optimal levels, and addresses them across that entire life cycle. So we're looking at maintenance programming updates, everything, you know, anytime we have failures on our equipment, you know, we'll consider doing fracas. We have to control engineering changes, right, and updates to the equipment, whether we're making them or the OEM is pushing them out and we are then implementing them. We've got technical manuals and other extant data that we use to support our assets. Training needs. I mean, if you're trying to extend the life of an asset that was originally designed to last X amount of years and you want it to go longer than that, you may be doing a service life extension project. The maritime industry is notorious for this in the military sector, because we'll design a ship that's supposed to last, you know, anywhere up to 30 years, but they'll get 50 years out of that asset by implementing a service life extension project. Of course, everyone's familiar with obsolescence, and if you're not, then you haven't been working with equipment long enough, but you know, things become obsolete over the years. And then of course we have to repair, upgrade, dispose, retire our equipment eventually. So we can use analysis to help us determine when that timing is most appropriate. So how do we do all these things? Well, we have a few core analyses that I'm going to focus on today for the sake of brevity and not overwhelming you with all these other types of analyses that are out there. But if I had to narrow it down to three kingpins, I'd say the failure mode effect and criticality analysis, the maintenance task analysis, and the level of repair analysis provide the most value to this effort. The maintenance allocation chart is something that is more heavily done in some branches of the service than others. The Army is very, very much focused on maintenance allocation charts. And that basically assigns or allocates maintenance to a certain responsible party as a result of the FAMICA. But before the maintenance task analysis is completed and a level of repair analysis can alter that decision. So the maintenance allocation chart basically assigns the responsibility of a maintenance task to a certain level and person in the organization. The maintenance task analysis itself is going to get into the nitty-gritty on the maintenance items and get down into the details about what is required to complete a maintenance task. Okay, and we'll talk about that a little bit more here in a bit. And then the level of repair analysis helps us determine where is the most appropriate level in the organization and resourcing to execute a repair. Okay, and it could be that the item should just be discarded when it fails. You just throw it away, and you don't get another one. You don't replace it. It's done. It could be that you repair it. You know, if it goes down, you actively repair it with your own organic resources, your own technicians in your organization. Or it could be that it's a replace item where you just purchase a new one and you do a direct replacement. And on the repair side, you may have more than one resource that's eligible to repair that item. You may have vendors on contract, right? You may have OEM providers on warranty. You may have just independent technicians that you hire to come in and do repairs for you to supplement your staff. So there's all these different options, and these analyses go hand in hand to help us develop a maintenance concept for each system. So when we put those 4 analyses at the center of our maintenance concept, and we iteratively repeat this cycle every so often, which we can talk about the appropriate way to determine that time period. Really what you're doing is you're reaching outside of those analyses and you're impacting all the things that encompass a true maintenance concept. Your maintenance concept should address your technical resources, your maintenance types. Which types of maintenance are you going to address with your own technicians or external technicians? Your spares, right? Parts replenishment. In the military, we refer to it as provisioning. Your tools, whether they be special tools or standard tools, your tools will be driven by the maintenance that you're conducting. Your training that's required to get your technicians proficient to the appropriate level, not more, not less, but the right level of performance to execute the maintenance that you're prescribing for them. And then, of course, you need information from technical manuals and other sources, and a maintenance model in some regards. In some organizations exists when you have more than one layer of maintenance professional accessing the equipment. So kind of all this stuff, when you bundle it up, is a maintenance concept. And at the center of it, you can iteratively perform these analyses to determine how to manage all of those things, all those different elements of your concept. Boy, that's a lot to swallow there, huh? All right. So look, we have a life cycle. It's great, In the early phase, you've got this concept or this, early definition of requirements of what we want this thing to be. And then as we move into design and development, we create a detailed design, and then we put it together and we get approval and we move forward with developing this thing, and we go into what's called production. And then we introduce this item, this asset to the user, right? And this is all on the design side. And if you're simply a user, you're not actually doing design work, you may be informing someone that you're purchasing an item from on those early phases of development, right? But once you get into in-service, that's where sustainment really happens. And you'll notice that under design, develop, and production and introduction, we have that one large iterative logistics supportability analysis kind of rotation of analyses happening there. And this is so we can start designing all this maintenance concept into the equipment and then modifying that concept to support this asset once it's produced. And then once we actually push it out into service, we're going to iteratively complete those same or less, depending on what you need to do. You can tailor it to your organization. You can repeat these analyses at different periods to support your in-service resources. And then eventually you'll get to disposal, where you're going to retire the asset. So this is a pretty cool way for you to see what the S3000L says about life cycles in relationship to the iterative nature of analyses. So what does this all mean, right? Like, we have to do something with this. There's got to be some flow of analysis. If you look at the top of this table here, or this picture, you'll notice that we've got comparative analysis and configuration aspects, both kind of partnered here. And on the comparative analysis side, we start with the influential analyses, this technical FAMI, the reliability analysis. Human factors engineers will come in and make sure that the item is designed to support a human being's operation of the system. And then it gets down into these foundational elements, which are the logistics supportability analysis, FAMI, a maintainability and testability analysis, and so on and so forth. Operations analysis, like how do we actually operate this thing? We have to create processes and rules and different support directions for the assets, so that we hand it to a user. They actually know what to do with it. They know how to properly operate it, properly observe its operation, so that they can get the most out of the asset. Okay, and that's going to define our maintenance needs, right? Out of all these things, you don't have to do all these things. You can just do a few of them. But out of all this work comes a maintenance task definition. We have now defined what the maintenance demand is for that asset on our organization. We know what we're going to have to do. At least we know what we think we're going to have to do, right? We haven't actually gotten out there and done it yet. So we get this defined list of maintenance tasks, and then we can go through a maintenance task analysis to determine what kind of resources are needed to support it: time, money, personnel. And then we can perform a level of repair analysis to find out now that we know a little bit more about the maintenance task, or a lot more about the maintenance task, what's the appropriate decision for repair, replace, or discard? And then we can, from there, determine what our training needs are, right? And then we can now support this tremendously awesome asset that we have in our disposal. So we go back to this chart and we say, okay, we've completed a FAMICA. Most people are familiar with the FAMICA. We've identified in the FAMICA what potential failures there are to the different requirements. All right, I'm trying to keep this simple for maybe some of our non-maintenance reliability professionals, right? There's a certain function that we want this piece of equipment to perform. If there's a failure, how can I determine when that failure has occurred? What's the impact of that failure? How am I observing the failure? What does it do to my operation? What's the probability that failure will occur? Is there any maintenance that we can perform to prevent this failure, or at least mitigate this failure from occurring? And if not, then maybe there's corrective actions that we need to be aware of that we can plan for based on the probability. And so we can perform the FAMICA, and then we can allocate the maintenance to the appropriate level. Okay, we haven't done a lot of analysis here. I mean, the FAMICA is a lot of work, but once we have that, we haven't really broken down the maintenance tasks yet. But we know that certain people in the organization are going to have to perform that maintenance. The electrical maintenance is probably going to the electrical shop, right? The main propulsion systems or diesel engines or electronics are going to go to those specialists. We can already determine that based on the failure mode and what we're going to have to do to fix it, type of equipment, the nature of its functions, operations, and design. So then we take those tasks and we're going to break them down, and that's what's next. Okay, we're going to really dive into the maintenance task and see how we're doing on the task itself. So maintenance task analysis is going to address all these things. Okay. We've determined that a maintenance need exists through FAMICA, and now we're going to go through the step-by-step process of completing the task. Okay, this could just be a dry run. This could be working with technicians that have already done this work to determine these things, but really what we're going to do is we're going to try and create this list of step-by-step processes to complete the task. Then we're going to try and record what's the total time required to complete this task. Some of your OEM, your original equipment manufacturers will provide you with information regarding repair, but they don't often include duration. You'll have to figure out how long it's going to take you to fix an item, and that actually, may have a significant impact on how long that equipment is down and impacting operations. So you're going to need to be aware of that. Labor, this is a little different than proficiency. Okay, we're looking at the number of technicians. How many people do I need to perform this task? The next part is, okay, well, what is their level of skill? Do I need a master electrician, or can I get away with a journeyman? Do I need a OEM certified mechanic? Or do I have the freedom to not impact a warranty by using my own personnel? Those types of questions. Let's see here. Next, we have parts. Of course, you're going to need components, units, items, however you refer to them, however your manufacturer is referring to them, you're going to need them. And then you have simple consumables like lubricants, rags, cleaners. We're gonna account for those as well. And then we have task frequency. Now, this is something that I found is very well managed in some organizations and almost not even considered in others. Is this, if it's a preventative maintenance task, is it going to be an hourly task, a daily, a weekly, a monthly? We can assign a periodicity to it, right? Some organizations are very good about that. Some just have a list of maintenance and they kind of play it by ear, and that's gives us something to strive to improve, right? We can continuous improvement, can get to the point where we can assign a frequency to the item if it doesn't already exist. And then of course you have to have references. Do I want my technicians doing this off the top of their head? Well, not if I can help it. If we have explicit directions, technical manuals, maintenance procedures, the drawing for the system, whatever applicable resources are needed, you will find those in the analysis. So this is an example of a maintenance task analysis form from Ben Blanchard's text, Logistics, Engineering, and Management, which is great, by the way, if you're looking for a good reference on some of these things. And in this example, you can see all the things I previously described. We have a task number, a task description, how much elapsed time there is for each of those tasks, right? We measure that. Then we have the frequency. We can determine the total frequency for the item. We've got the manning minimum for personnel, right? So we know the different levels of organization. You know, we have basic, advanced, you know, whatever you guys refer to in your particular discipline. And then we can total up those hours, and we can determine how many man hours are dedicated to the task, how much time it took to do the task, and how frequently we need to do it. And then we can move forward from there. Pretty cool stuff. This is an example of some information that I pulled off of Coast Guard maintenance procedure cards. These were for depot maintenance tasks that the Coast Guard had already allocated to a depot maintenance provider for an engine. Okay, so they had a cylinder head conditional replacement item. This was more for, you know, not necessarily a routine task, but they had a card already developed based off of the tech manual for this piece of equipment. We could tell how many hours for each cylinder head were allocated, the number of technicians that were needed, how many team labor hours were included, so I knew how much time the team would be on site, right? And then we had each level of enlisted technician accounted for by hours. We could take that card and say, okay, for the cylinder head, which is the second maintenance item on this list, I need one E8, which is a senior chief. I need one E7 chief. I need a first class petty officer, an E6, and then I need one E5 and one E4 to do this task, right? And I can't really see over there, so I'll just move on from that. And then what we can do is we can actually sum all of these labor hours to determine how much depot maintenance is required for this asset, just on a planned basis. This isn't a reflection of performance yet. This is a prediction on how much we think, in accordance with the manufacturer of the equipment, how much time we're going to spend in man hours performing depot maintenance on this engine. So, all right, so once we finish all of that, right, we do the failure mode, effect, and criticality, we do the maintenance task analysis. Now we're moving into level of repair analysis. And this is kind of my little, you know, my little bundle of joy here. I'm not going to get too crazy with it. But this is what I did my doctoral research on. Level of repair analysis in its simple form is just an analysis which tells us, hey, where are we going to replace, repair, or discard this item based on cost, our maintenance capabilities, our readiness, our safety, environment, and requirements. Okay, and this is the Coast Guard definition of a level of repair analysis. So we'll want to analyze our maintenance support alternatives, meaning how many different alternate sources of maintenance support do I have? Do I have my own people? I have contractors, I have OEM providers, and I'm going to look at the economic and non-economic factors related to the maintenance performance by each of those resources. And then I'm going to use the results of this analysis to help me develop maintenance plans, okay, and an effective structure, because I may have to alter my own organization structure to meet the needs of this new asset that we're purchasing. You know, I think a lot of people assume that they're going to make the asset fit their organization, but that would be very presumptive, right? Like you want to make sure that you are aware that you may have to adapt to the asset, okay? So you may need to request new resources. You may need to procure new resources, and you're going to be able to use the level of repair analysis to justify those things. So we do the non-economic analysis first, then we follow that with economic analysis, then we perform a sensitivity, and a real simple one's a one-way sensitivity, and I'll show you an example of that. And then you're going to want to perform some sort of decision analysis with your leadership, okay? And I recommend that you tuck risk into that decision analysis. Don't forget the risk analysis, okay? That is going to heavily impact your decisions. The higher you get in the organization, the more risk should be considered in the decision analysis. So this is my model for LoRa. Don't worry, we're not going to be quizzing everyone and asking you to memorize this. Simply putting this up as a reference for you to see the model I came up with for performing a LoRa. As you can see, it covers all corners of supporting an asset. In the non-economic analysis, we're going to be looking for answers to questions. We're going to go, all right, is there already a maintenance philosophy or concept alive and well in my organization? What is the maintenance philosophy or concept or program that's being provided to me by the original equipment manufacturer? What kind of training is required to maintain the asset? Can I use existing maintenance data, or can I even get my hands on any maintenance data whatsoever? If I don't have any of my own, can I get it from the equipment provider? What is my supply chain demand going to be? Do I even have a sufficient supply chain to support this asset? Or are we running on one person ordering all the parts for a 50-acre shipyard? It would be crazy, right? What about contracting requirements? If anytime I engage an outside source for work, there should be some type of contracting consideration to be taken into account. And then, of course, we have knowledge resources, which are those tech pubs, the equipment provider. Some equipment manufacturers are very willing to share information with you about their assets. Others don't provide much. I mean, I've had a very complex systems procured, $1 million system, and you get a pretty decent, not all inclusive, but pretty decent suite of technical information to support it. Maybe here's our recommended preventive maintenance schedule and actions. Here's an actual parts list for your equipment. And then I've had other systems where all you get is like an advertisement for the piece of equipment, right? Like the same thing we gave you to help you make a decision to buy our services is all we have to provide, and it's like, okay, great. That's not going to be very helpful for analysis. So. And then, of course, I need prices, and I need to understand in the economic analysis how much resource demand there's going to be on the maintenance task, right? So the maintenance task analysis needs to produce the maintenance task information. I need to relay that into costs. If I know how many hours people work, I need to know how much those people cost me an hour. That's the maintenance costs per man hour on the left side there, right? We had Coast Guard technicians as resource 1, and we had non-Coast Guard technicians as resource 2, and we just kept it real simple. You're either using your own people or you're not. And we made some basic assumptions on this acquisition with this. And then what we can do is we can put all this stuff together and figure out how much this maintenance task should cost us per performance, right? Every time we complete the maintenance, how much is it going to run us? And we can look at averages, and we can look at minimum and max costs across these different resources, and we can start to get an idea about how much different resources are going to cost us to perform this task. We can also determine how much is our supply chain going to cost us, right? Like we're going to have to incorporate all of those supply chain figures into this analysis. So once we do that, then we can perform a sensitivity analysis, and that will give us the ability to change a variable that we feel is unstable. Maybe it's if you're talking about petroleum products, it's the cost of petroleum fluctuates frequently. It could be the cost of raw materials. It could be labor sources. I've got a very unstable labor market, and I'm not sure if they're going to cost me $100 an hour or $200 an hour from week to week, right? So you can change a variable in the equation and see how the costs all work out for you to determine whether your decisions are still remain the same as those variables change. And then, of course, you're going to have to make a decision about all this. You're going to say, all right, now that I know all this stuff, I've got all these figures in front of me. I know how much time and money it's going to cost me and what kind of people and tools I need and all this stuff. Now I can make a decision about, hey, maybe we should update the maintenance philosophy or concept to say we're going to depend on the OEM provider because they're the best option, right? The lowest risk, maybe not the best cost, but they're still the lowest risk. And right now, operational availability is king, and we can't afford to get smart on this equipment quickly. So let's take our time getting smart on it, build up some proficiency, and then we'll transition away from the OEM manufacturer in 5 years. And we can make a decision based on that, based on these outputs from these analyses. The other thing we can do is we can confirm that we have our logistics requirements established properly. We knew we were going to need training. We knew we were going to need maintenance teams. We knew they were going to need these things. We knew we were going to have to contract support. But now that we have actual figures to assign to those assumptions, we can update the training resources or the maintenance team resources or contracts accordingly. So when we talk about different maintenance philosophies and models, the Coast Guard's is pretty basic. A lot of other services have gone to this bi-level maintenance model, which means really that we're just going to do maintenance in 2 locations. We're going to either do it at the organizational level, or we're going to do it at a depot level with OEM or some type of outside contractor. when I did the analysis on the Coast Guard's asset, we took it and we broke it out into those two halves and said, okay, who does organizational maintenance? Well, it's the ship's crew. And Coast Guard ships are called cutters. So it's the cutter's crew is my only resource option on the O-level maintenance side. On the D-level maintenance side for the Coast Guard, we had a ton of resources. We had the maintenance augmentation team, which is like a local team of advanced technicians they have. We had an industrial production facility in the same port, contractors that were on tap to help. And we had this thing called the Assist, which is like a crack team of expert master chiefs that the Coast Guard could deploy at the drop of a hat to go fix problems that no one else can figure out, right? So we had all these different resources. We could actually assign values to these resources now and determine what mix of them is appropriate for which maintenance items. So just giving a little example of how the analysis goes hand in hand with the philosophy. Okay, so when you do the non-economic analysis, you're going to go ask questions, all right? You're looking to determine the most cost-effective method to sustain your system across the entire life cycle. That's why we have to do this in iterations. So we're going to look at our resource options, right? All the things I've already told you about. We're going to look at all of those things. We're going to look at the availability and worthiness of data. That's a really big one, right? Especially in the world that we live in now, where everyone's trying to buy software and buy databases and buy cloud services and buy all these things that are going to help us organize and store and pull apart data, right? So we have to look at the availability of data. Is it even in my hands? Can I get a hold of it? How valuable is that data? How accurate is it? Okay, that extant data that's going to inform our analysis needs to be dependable. And if it's okay, well, at least we know that. And we've made that determination, and we can inform decision makers of the confidence that we have in this data so they can assess the risk of their decision against that confidence, right? So this is all very powerful stuff for you to be able to hand up your chain to get buy-in from your sponsors and from your leaders in your organization. If they're kind of looking down their nose at your analysis, you can make all of these arguments in your favor. Okay, and then of course we have to consider the operating environment. Good example of this would be if you design a piece of equipment to operate in one type of platform and environment, you're putting it into a different platform and a different environment. You have to try and capture the impact of those environmental changes on the availability and maintenance of that asset, okay? You can make some assumptions at first, but as time goes on and you get in service, you can now start capturing performance data from the field and feeding that into this non-economic and economic analysis. All right, and then of course, the supply chain. So when we did a one-time run of this one ship's depot maintenance for one engine, we found that if we paid the Coast Guard's team to do the work, it cost about $21,000. If we paid the non-Coast Guard team, it was $57,000, right? We could round those up to 22 and 20 or 58 if we wanted to. If we made a blended team, we could strike a bargain kind of financially closer to the Coast Guard's value and bring in non-Coast Guard team members with industry expertise to kind of guide their effort and reduce our labor costs. So the blended team ended up being the best option for the Coast Guard. And if we had only considered one option or the other, we never would have gotten to the point where we could say, wait a minute, we can blend this team and bring in some OEM expertise, but use the Coast Guard's labor force to perform the vast amount of hours that are going to be required to do these tasks. Okay, we had some sunk costs. Our special tools had already been purchased for us by the acquisition initiative, so I didn't have to worry about those. I would have to worry about replacement if I was going to have to do replacement. Tech data was already provided to us financially by our acquisitions directive as well. And just for those that aren't familiar, there's two different pots of money. So we could call that a sunk cost. It's not going to be a cost to my budget as long as it exists. Okay. And the maintenance facilities. Now, if you work in an organization that doesn't separate acquisition money from sustainment money, right? Doesn't separate purchase funds from or recap funds or recapitalization funds from operating and maintenance funds, then you're going to have to make sure you put this together. And then the maintenance facilities themselves have been there for 100 years, so we didn't have to invest in those. So the cost of upkeeping them and keeping the utilities alive in the building were considered sunk because of the way the money flowed in the service. But if you had a remote operating facility in your organization, you don't want to account for those maintenance facility costs as well. Okay, and some of the neutral costs we had were the supply chain for that engine was considered a neutral cost across all of our resources because the OEM was the sole source provider of those parts, and they were the sole source provider of non-Coast Guard technicians. So really it was a wash. I had to buy the parts from them, whether I did the work or they did the work. Made it pretty simple for us. Okay, picture speaks 1,000 words. This is why we chose blended teams. If you look at how the chart works out in our favor, you can see that the blue team bars here are the Coast Guard labor. The orange are the contracted labor, and the little gray column behind both of those is our blended labor. Okay, and you can see that for the most part, the blended labor is the wise decision because we can reduce risk and keep cost under control, but we still have increased our proficiency because we've got that expert on site. You can see that they're significantly cheaper if we went with all gray bars versus all orange bars. And they're, not terribly more expensive than all the blue bars, right? So this is a great thing to show leadership, because no matter how many numbers you show them and all the great things you tell them, sometimes they have to see it to believe it. And when we put this bar graph up, they went, oh, wow, look at that. So, don't be afraid to go ahead and break out your maintenance tasks, show the costs per task amongst all your different resources, and try and drive your point home, help you sell it. Okay, so getting close to the end here, Maureen. We've got to ask ourselves some questions during the decision and risk session. These are not decision analysis points, right? They may be incorporated in your decision analysis, but this list in and of itself does not satisfy what it would be defined as a decision analysis. It's just good things for the asset manager and the maintenance manager to keep in mind as they're working with leadership on decision and risk questions, right? We kind of made it so that it was a good or a bad. There wasn't a mix, right? Like yes wasn't sometimes good and sometimes bad. No wasn't sometimes good and sometimes bad. We wanted to keep it nice and clean so that when we could calculate all the yeses and nos and make everybody feel good. So, we ask questions like, is the cost of maintenance acceptable? That sounds subjective, right? It might be acceptable to some people and not to others, but I'm not really worried about others. I'm worried about my organization's expectation, budget expectation for the cost of maintenance. So is it acceptable for what we are buying? Is this an acceptable amount of maintenance cost? We should be able to determine that, right? Are the support elements in place to make sure that we're successful in sustaining this asset? In other words, we're buying it, we're going to spend all this money. Now that we've done all this analysis, do we even have the support elements that we analyzed? If we don't, we need to invest in getting them, okay? That might change which way your decision goes. Is the proposed maintenance appropriately funded? Which is a different question than the first one. The first question is it an acceptable cost? The third question is the proposed maintenance appropriately funded? Do we even have this funding? It may be an acceptable maintenance cost, but we haven't been able to get the budget for it. Okay, that happens quite often. Is the unit in acquisitions? Okay, if it is, we haven't fully transitioned to sustainment yet. We have some time to get things in place. So you can move through the list and you can kind of determine, capacity, flexible and responsive resources, all these different things that really are kind of what stick in the planners and managers' heads. Now, the sensitivity analysis, what we found was when we looked at 1 year of performance on similar assets, because we didn't have this ship yet, but when we looked at similar assets that were already in commission, things that were already halfway through their life cycle or even more, we were able to capture the maintenance team's performance and determine for these similar tasks, what was the most unstable variable. Okay, so when we looked at the maintenance task analysis, we found was the duration of the task was our most unstable variable. Some of those tasks, one being the prescribed amount of time that we said the task should take. Some of them happened a little bit faster, but we shouldn't make this expectation that you can perform a maintenance task much faster than its prescribed period, right? Because you start to introduce risk and failure when you do that. You're rushing a task, okay? So we gave the 0.8 as a little bit of a way to go, okay, maybe you're becoming more efficient, but that's not really where we're trying to go with this. We're trying to see where the risk is. The higher risk was in the cost of tasks taking much longer, because the trend was going toward longer maintenance tasks as the life cycle drew on, because we started to find more interferences. And you know what? These bolts are getting weak and breaking because of age and heat and cold and heat and cold and heat and cold, right? So as we went through the life cycle of the asset, what we found was task durations were sometimes up to 3 times what we had prescribed they should be, okay? So we made the assumption that we would calculate duration, sensitivity, This is very simple. It's just a one-way sensitivity. It's not multivariate. You could do multivariate as well. Okay. And we said, all right, well, what happens if it does take us longer? How much is it going to cost us? And we broke it down into increments of the hours, 1 hour, 1.2 hours, 2 hours, all the way up to 3 hours. And we saw the cost of the non-Coast Guard labor rate at the 3-hour mark was significantly higher than the Coast Guard. And you could see that the blended kind of stays in control, right? It looked like a fairly controllable cost, something that was a little bit more appetizing, right? A little bit more appealing than, say, just strictly depending on non-Coast Guard labor rates. So the goal was to drive toward a blended approach until we could be fully self-sufficient. Now we look at some of the non-economic elements, because we're talking about this budget, we're talking about the cost of maintenance, but let's look at it realistically. You're not going to be in full control of those things, but you do need to make recommendations about what you're buying. And those are your non-economic things, right? Training, the maintenance team, maintenance procedures, right? The task development, building your training facility and staff, if that's what direction you're going in. If not, how do we procure training? Do we have the location? Do we need to go somewhere else? What's this? Now there's travel involved, right? We can start talking about all those things. There's cost, but there's also efficiency, effectiveness, people being taken away from the facility to go to training, all these things. So we mapped out 10 years worth of sustainment here and said, okay, in the first 5 years, we're still heavily dependent on our equipment manufacturers because we're in acquisitions. As we transition out at 5-year mark, we feel like we can start breaking away from the OEM a little bit, but we're still going to need them on tap when we need them. So let's renew their contract, but revise it so that it's not so heavily dependent on OEM, kind of putting them on a, we've got you on the other end of the phone when we need you kind of thing. Conducting training, front-end analysis is just basically at that point, we're trying to develop our own training because we've been getting training from another provider for years, and we feel like we can now take over doing this ourselves organically. And so we're going to start building those courses. So for 5 to 8 year, we're going to conduct the analysis to build the training. And then from 8 to 10, we're actually going to build the training. And then at the 10-year mark, we are fully sufficient. We're in sustainment, sustained depot maintenance activities. We're going to do all this advanced maintenance by ourselves. We're generating our own training. We're generating our own performance data. We're relying on OEM for less and less as we go on. And that, for the Coast Guard, was the most ideal situation to be in. And that is a summation of sustainment engineering. So here's some contact information if you ever want to get a hold of me. Probably quickest to get a hold of me via LinkedIn. I work for BMT. We're a ship design and consultancy firm. There's my email address. You're more than welcome to email me if you need to reach out to me for a conversation or services or whatever. A couple things that are coming down the pipe. I've been trying to write a book for about a year now, and I've been so busy, it's taking longer than I thought it would, but I'm working on it. We're making progress. It's going to be great. Also, providing sustainment engineering training, and I'll be schlepping around some conferences in 2020 if you want to run into me and have a cup of coffee and talk. Plan on being at least one SMRP function this year, MARCON and IAM. So.
Awesome. Well, thank you, Lucas. And I also highly recommend, if you guys are on LinkedIn, hooking up with Lucas over there as well. Good information sharing and things like that. So, but yeah, so we did have a couple questions come through, and we've got some time here. So, folks, if you've got questions, toss those over. We'll try to get to the ones we can, and if we don't get to everybody, we can certainly get Lucas to be in touch with you offline. So one question that came in actually a little bit earlier in the presentation, but I didn't want to interrupt you on such a roll, was kind of how what you were talking about today, how it relates to the requirements of an ISO 55000 strategic asset management plan. So for folks who are living in that world, kind of what are the similarities, or how does these things align?
Okay, yeah, actually, that's a great question. So if you're really truly trying to live out 55,000, the series of 55,000, then you're trying to create both strategic and localized asset management plans, right? So your strategic asset management plans can be informed by these very robust analyses that have basically helped you develop your maintenance philosophy. So as you've created these maintenance concepts, you're feeding that stuff up the chain for approval, but it's also going across the chain to create a culture that respects the work and demand of maintenance to sustain operations, right? So if asset management in the sense of 55,000 is truly about tying business goals and objectives to maintenance goals and objectives and operating goals and objectives and all these goals and objectives at the lower levels of the organization where stuff is actually happening and not just being talked about, right? If the goal is to try and tie all of our work at the tactical and operational levels of the organization to those higher level business goals for maintaining and sustaining our assets, then this analysis or stream of analyses or iterations of analyses give us the ability to constantly check and adjust our strategies, right? Which will help us better meet those business goals and objectives that are established in 55,000, or not established in 55,000, but prioritized in 55,000 for linkage. Because true asset managers are looking at this from a very strategic perspective, right? There's a lot of trying to blend AM and maintenance and reliability in this world right now, and there is a lot of overlap, but they are two distinct things, right? The asset management is a cultural and strategic approach to taking care of all of your assets. This gives us a better way to do that, right? So you can make an argument that these analyses create a defensible and rigorous way to do more than just talk about and guess what these things are going to cost us and plan for, right? We can actually feed them in and say, hey, look, part of our goals for our asset management or strategic asset management plan this year were to, revise our approach to maintenance in these critical areas of the organization, which have direct impacts to operational capabilities, which have direct impacts to our asset management strategy of, improve our operational uptime, right? Or whatever it may be in regards to your strategic asset management plan, or look at recapitalization for a major piece of equipment at this period in its life cycle versus this period. Many asset managers are looking at, okay, we need to start looking at recap costs earlier, right? So how are we doing that? We can start to use these analyses to say, well, this is how much we think supporting our existing asset is going to cost, and how much procuring and sustaining a new system would cost us. And at a certain point, you could start to see the benefit going toward purchasing a new item, right? So that might be helping your strategic asset management plan. And then, of course, as that trickles down to your asset management plans at the systems levels, obviously it's a little bit more tailored and specialized to the system. But yeah, hopefully that helped.
Awesome. All right, so here's another one for you. Were you able to reduce your spare parts failures when you shifted from the OEM PMs to your own maintenance personnel PMs?
In some cases, yes, and in some cases, no. Okay, because what we found was we were over maintaining our equipment to a certain degree in some areas of maintenance, based on the OEM recommendation. A good example of this would be at the diesel engine overhaul period, right? We have gone way into the life cycle on these engines. This isn't the same engine that we analyzed. This is another engine that we analyzed. We had engines that had been in service for 20, 30 years. We had been following the manufacturer's prescribed overhaul periodicity for those engines because they're massive, they're expensive, they stay in that ship basically until the ship is decommissioned. So you do whatever you can to keep that engine running in that ship. So we had been following these periodicities, but what we were finding was when we were executing the maintenance, we were finding that a lot of the components we were pulling out were in serviceable shape still. And so we went, maybe we need to revise our approach to the maintenance periodicity here. And we implemented a condition-based maintenance kind of approach where we said, all right, let's do diesel engine inspections on this piece of equipment versus overhauls, and we'll just move the inspection period a little bit earlier than the overhaul would normally be. And then we'll be able to make an educated decision about overhaul once we've completed that inspection. So what we did was we calculated the cost of those inspections, and then what we found was we were actually able to offset overhaul costs which offset the cost of our spares because we weren't buying so many pistons and conrods and bearings and cylinder liners and all these things. And we did it without negatively impacting operational availability. Right? We didn't, start to experience a significantly increased rate of casualty on this particular engine. And I can't say that won't happen in every instance, but the more attention you pay to this stuff, the better you'll be able to predict that. So yes, we have had instances where we've been able to do this to offset some spare parts costs and reduce some. And then we've had instances where, your analysis was flawed because you didn't use the right data, or you didn't use high confidence data, or you did the analysis inappropriately, or whatever. You tried to make it say something that it wasn't actually trying to say, just so you could leverage the power of analysis in the wrong way, and it comes around and bites you because that piece of equipment really doesn't care what your number was. It's not reading your report. It's going to do what it does. So yeah, you get both. You just have to be responsible about it.
Yeah. And one thing I noticed that kind of weaved throughout the whole presentation was kind of the human factor, and you mentioned training, numerous times throughout. And just wondering, for those who, everybody knows that training is so important and everybody needs it, and we need to be, focused on that, but it's not always the easiest thing to get funding for, or time, or whatever. Any kind of advice on that, or sort of sales pitch, how folks can kind of overcome those hurdles when those training dollars are just not being forked over?
Yeah, I think for you to truly sell training to hesitant buyers, you need to show them the value of the training. It has to have some return on investment, right? I mean, we're talking to business people here. When we start getting to the level of fighting for a budget, you need to be able to argue with a non-maintenance engineering, maintainer type. You're making a case to someone else, not one of those people that you need these things. Hopefully you're not having to convince someone that knows better that it's valuable, right? And so what you need to do is you need to produce, hey, what's the return on the investment? And in a case of buying a new piece of equipment, you're so unfamiliar, depending on the complexity and the maybe the lack of familiarity with that particular piece of equipment, you make a pretty good argument in the beginning that training is going to be required. Okay, it becomes more difficult to sustain that request as the life cycle carries on, because people have a very short but sticky memory, and they're like, well, we've already paid for that, right? So what you need to do is you need to make sure that you incorporate it into the culture of your program. And you need to try and incorporate it into the asset management conversation, because as we said earlier, asset management is not a tactical operational type discussion. It's a more strategic discussion. We need to be feeding those things up into the asset management strategy so that they can get that level of buy-in, so that there's less resistance from the top down on supporting that training. Now, I'm not stupid, and I understand that when things get tight, training is usually one of the first things to get cut. Again, you need to show them that you're not going to sometimes realize the value of training in the immediate future. Sometimes you will, sometimes you won't. But what is the overall cost and benefit of that training? Okay, if you say that I can give a person training today, and 6 months from now, we'll have a reduced instance of failure on this piece of equipment based on our historical performance with people that have had that training, well, then you've got some pretty good argument. Now, if they shoot you down, they shoot you down, and well, you might be trying to get creative with it, right? And train your own staff and do those things. But you really do have to kind of be the bastion, the sponsor of the return on the investment. That is, to me, with the most critical part, because a lot of times they don't understand what you're getting training for. They just know that it costs something. You need to show them how that's going to benefit the program and not just a person.
Awesome. All right. Well, I'm going to take the screen back here. Just a couple closing slides, but thank you. That was awesome. Some great discussion. And like I said, everybody, connect on LinkedIn. It's a great place to kind of continue these conversations and things like that until those in-person coffees and whatnot at the various conferences throughout the year can take place. So highly recommend everybody staying active in that space. But just real quick in closing, and again, Lucas, thank you so much. This is awesome. And again, if you missed the very beginning, I did let everybody know I did record this. So I'll have it up on our website and share a link out on social media and things like that. later today, so you can have another listen if you need to, or share it with those who need to hear what was just said. But our next webinar is coming up actually in just 2 weeks. We've got Rob Kalawarowski. I feel like I should know how to say that by now, but he's from Rob's Reliability Project. He's got a podcast. He's also really active on LinkedIn and shares a lot of great information. And he's going to come on and talk about what are your KPIs hiding. So another pretty cool topic for us. We like to, not just be all ultrasound all the time, because we know ultrasound is just a piece of these bigger picture topics. So if that's of interest, I'll be getting an invite out for that. So hopefully folks can join us for Rob's webinar. And then with that, I'll just leave our contact info up here so folks know how to get in touch with us. If you think of additional questions for Lucas and you didn't get his contact info, you can certainly just email me. I can connect you guys. But yeah, thanks again for everybody joining us in today. And I hope everybody has a great rest of your day, and we'll catch you guys later.